video we are going to discuss about the packing efficiency in primitive cube. Packing efficiency in primitive cube. So what do you mean by packing efficiency? So how densely it is packed and how much the space is available for the atom and how much space is empty in the box. If just you consider that you are having a cotton box and in that you are placing a football. So football will be placed at the center and the rest of the space at the corners will be empty. So when we are calculating the packing efficiency of this football with respect to the box is a cube and the football accommodated, okay, the ratio of the space available by the football and the total space available inside the box. This will be the packing efficiency. Similarly, we will consider here the atoms are accommodated at each corners of a normal primitive cube. At center we are having the empty space, that is called to be voids, the empty spaces. So here we are going to find the ratio of the empty space with respect to the atoms accommodated space. So packing efficiency is space occupied by the atoms by the total space available. Total space available. So here this is a cube. The total space available here will be the volume of the cube. Space available or the volume of the cube. Volume of cube, that is A into A into A, that is A cube. We know that in the earlier classes itself, right? And what is the space occupied by this atoms present here, right? I just consider only one face of the cube, that is ABCD, as mentioned in the diagram. So the atoms will be accommodated here in this manner. So the center space will be empty spaces which is not available by the atom. So only the corners will be available by the atom. In three-dimensional manner, every corner is accommodated by 1/8 part of an atom. Okay, just consider the space. Here the A, that is nothing but the edge length. Edge length of this, that is A is considered to be the radius of this atom and again radius of this atom also. So 2 times the radius of the atom contributes A. So here we are having a ratio called 2R, that is considered to be A. So 2 times the radius of the atom is considered to be the edge length. And to find the volume of sphere, we are having the formula volume of sphere is equal to 4/3 pi r cube. And coming to the packing efficiency calculation, packing efficiency, that is equal to the space occupied by the atom. So totally here we are having 1/8 part of an atom at 8 corners, that will contribute to give 1 atom. That means 1 sphere completely. So volume of the sphere, that is atom, into the number of atom is 1 divided by the volume of the space available, that is nothing but volume of a cube. So here we are having 4/3 pi r cube into 1, that is the number of atom, divided by A cube, and A cube can be rewritten as 4/3 into pi can be 22/7 and into r cube. This A cube can be written as 2r the whole cube. 2r the whole cube. Then it will be 8r cube. So r cube will also get cancelled. So finally we will have 4/3 into 22/7 into 1/8. So the packing efficiency here is 52.4. Okay. In percentage, the volume occupied is 52.4%. The rest will be the empty space.